Section 6.2, Part 3. Our next example involves a fraternity, and it says, in a fraternity with 30 members, 18 take mathematics, 5 take both mathematics and biology, and 8 take neither mathematics nor biology. How many take biology but not mathematics? Okay, so they're telling me that the number in the universe is equal to 30. We're going to call our two sets M and B for math and biology. So we know the number taking mathematics is equal to 18. 5 take both, that's the intersection. So math intersect biology is 5. And we know that 8 take neither of them. So the number in A union B complemented. So outside that union, both sets, whoops, not A, M. Boy, am I fixated on A's and B's or what? So M union B complemented is the 8. Now, it's not necessary that you come in and do this, but to put the information on the board, this helps quite a bit. Okay, so our two sets are going to be M and B for mathematics and biology. So here's M, here's B, here's our universe. So always start with that intersection. We know that there are 5 that are taking both classes. We know that there are 18 in math. Well, we already have 5 accounted for. So to get to the 18, we need 13. So we've used this piece and this piece of information. We know that there are 8 people sticking out here that are not taking either math nor biology. Okay, well, we need to figure out this guy. So to do that, we already know what we have on the board. We know that we have to get 30 as our total. So if we take 30 and subtract off the 13 plus the 5 plus the 8, we'll get our answer. Well, 5 and 8 is 13. 13 and 13 is 26. So this is 30 minus 26, which gives us 4. So this region over here, that's the question mark, ends up being 4, which is the answer to the question. How many take biology but not mathematics? 4 take biology but not mathematics. So again, we're letting the picture of that Venn diagram do the work for us. Okay, our next example says, of the 18 students in the cycling club, 12 own a road bike, 8 own a mountain bike, and 1 own no bike. How many students own both types of bikes? I'm going to use M and B again. Oh, no, I'll use what? R for road bike. And let's use M for a mountain bike. Okay, what do we know? We know that 1 student owns none. So I've got 1 sitting out here. Ooh, I know that altogether we have 18 people. Okay. That's our union. I know that 12 own a road bike. I know that 8 own a mountain bike, but I don't know how many are in the intersection. So I'm going to let X represent the intersection. Now I made a slight error here, and I'm hoping you recognize it. So over on this side is the number in R union M. That would be equal to the number in R plus the number in M minus the number in the intersection of the two. However, we know that there's 1 person sitting out here. So 18 is not the union, 17 is the union. Okay, well, 17 then is going to be equal to 12 and 8, which is 20, minus X. So that'll give me a -3 is a -X. So X is equal to 3. Let's see if that works. So what we're saying is that in this intersection, we've got 3. So in terms of the road bikes, which were 12, that would give me 9 because together they add to 12. Over here, we need a total of 8. We've got 3. That would give me 5. And if I've done everything correctly, 9 plus 3 plus 5 plus 1 should get us back to that original 18 that are in the club. Well, 9 and 1 is 10. 3 and 5 is 8. 10 and 8 is 18. So sure enough, we get back where we needed to be. So far, all the Venn diagrams we've been doing with numbers have just been in 2 sets. So let's go do one that's got 3 sets and see how that goes. So our next example says let A, B, and C be subsets of a universal set. And then here's the information. So the number in the universe is 100. The number in A is 28. The number in B is 30. The number in C is equal to 34. The number in the intersection of A and B is 8. The number in A intersects C 10. The number in B intersect C is equal to 15. And then finally, the number in A intersect B intersect C is equal to 5. And then they're asking us some questions. Let's get our Venn diagram on the board first to help us out with what's going on. This time we'll use 3 sets. So our 3 sets are going to be, again, I'm going to make it fairly large so that I can put all 3 sets and numbers inside those sets. So here's set A, here's set B, here's set C, and here's our universe. So just like we did with the 2 sets in a Venn diagram, we started in the intersection of all 3, of all 2 of them. So now we're going to start with the intersection of all 3. We're going to put that 5 right smack in the middle of everything. That's the intersection of A, B, and C. Then we'll work our way out by subtracting. So we know the number in B intersect C. B intersect C are these 2 regions. We need 15. We have 5, so that's going to put 10 out here. So again, these 2 add to give me the 15 that's in their intersection. A intersect C are these 2 regions. We need 10. We've already got 5 accounted for, so that puts 5 over here. Again, 10 are in the A and C together. A and B intersect is 8. That's these 2 regions, but we already have 5. So we're going to subtract our way out and put a 3 right there. That gives us our 8. So far, so good. Now we're going to backtrack to C. So C is 34. Right now, C is a circle of a set, has 5, 5, and 10. That's 20. 20 from 34 is going to give me 14. So again, what we're doing to get this is taking 34 that we have, minus the 5, minus the 5, minus the 10. So to get, that's this number. So to get the 30 over here in B, we're going to start off with the 30. We're going to subtract off what we already have in that circle. That's the 3, the 5, and the 10. So that's 18 from 30, which is going to give me 12. Okay, over here in set A, right here, we need 28. Well, we already have 3, 5, and 5. So minus 3, minus 5, minus 5. So that's 13 from 18, which is 15. And that's going to give us 15. So again, we subtracted our way out of them. Okay, all that's left is to figure out that universe. To get the universe, what we need to do is to add all our numbers together and then subtract from the 100. So to get this number, and again, this is just to help you with the notes. We're going to come in and add everything we've got and subtract it from 100 because that's our universe. So we're going to subtract off the 15, the 3, the 12, the 5, the 5, the 10, and the 14. So I'm going to add them all together first, then subtract from 100. And if you do that, that should leave you with 36. So the number sitting out here is 36. And there we've made our first 3-set Venn diagram. Now let's answer the questions. I'm going to get rid of all the extra stuff because it kind of messes up on our understanding or our pictures in order to be able to answer questions. So there we go. I've cleaned it up somewhat. Okay, so part A is asking us to find the number in A union B. So the number in A union B. So we need everything that's in A and B. So A has got 15 plus 3 plus 12. So that's this one, this one, and this one. We're going to add these guys in too because they're inside A or B. So the 5, the 5, and the 10. So 15 plus 3 plus 12 plus 5 plus 5 plus 5 plus 5 plus 10 comes out to be 50. So there are 50 that sit inside the circles that make up A union B. Part B is asking us to find the number in A intersect B intersect C complement. So let's go do some check marking again, just to make sure we find what we need. So we know that A is this one, this one, this one, this one. B is this one, this one, this one, this one. And C complement is everything outside of C. So that would be this one, this one, this one, and this one. Because we're looking for that intersection, we need the region that has 3 checks, 1 for each of the sets we intersected. The only region is this region right here. So our answer to that question is that 3 that's sitting up there. And that's A intersect B intersect C complement. So, okay. Gonna get rid of my checks so I can do the next one. Part C on that problem is asking you to find the number in. We're going to do A union B union C, and then we're going to complement that. Oh, wait a minute. A union B union C is everything inside those sets. Everything inside those sets. And the complement of that would be outside of those circles. We already know that's the 36.